Hello. This is my Lab 8 implementation. To start off, I'm just going to explain that most of my code and everything comes from this YouTuber who posted two different videos. One was writing his own malloc, and then one was also writing the garbage collector for that malloc function that he made, as well as like free and other functions that he has in there. So moving over to code, here we have a header file. And in this header file, we have our main memory location that we're mostly going to be going off of and allocating pointers to inside of this heap here, which is every element inside of here is the size of a pointer. This is going to be used for later when we're actually searching for pointers and actually doing the function of the garbage collecting. We have a base. We have a different global values in here, global variables in here for use later. We have a structure here. The first structure is basically a chunk of memory, and there's just a pointer to the start of the memory, and then the size of that memory, similar to how we did it in Lab 6. And then there's also a list of chunks. So we have the size of the size of the list, so how many chunks are actually in the list, and then a pointer to, or I guess a list of chunks. I suppose not a pointer, just a list of chunks. And then we have three different lists that we're going to actually be using. So we're going to have a list of used chunks, a list of free chunks, and a list of temporary chunks. And the reason I chose, or he chose to do these or three different lists, I think if I went back through this, I could actually change the fact that he uses a used and free chunks. And just like in Lab 6, when we do the type of a chunk, so it could be an allocated chunk or a free chunk, I think I could go back through this lab specifically and do that, but I wanted to get a different point of view and actually see how it would be implemented using a list of free chunks and a list of used chunks. The rest of these are just methods that will be talked about in the C file. So moving on to the C file, we have a chunk list here, the used chunks that I was referring to before, which is just initialized to 0. It's got nothing in it. You have no allocated space to start. And then we get to the free chunks, which is a list of chunks that has an initial chunk in it. Just like when we started in Lab 6, we have that one giant chunk of memory that points to the beginning of that memory section. So it'll point to the beginning of the heap, and it will just be the size of the heap, essentially. So just one giant chunk to start in this free chunks list. And then we have temporary chunks, which is mostly used later when we merge chunks, and it deals with the fragmentation. So it mostly just deals with merging the different fragmented chunks. So we have some different basic chunk operations or chunk list operations. So each one of these takes in the list itself, depending on what it does. So this one just dumps the memory dumps the actual chunks that's inside of these chunk lists. Pretty straightforward with that one. This find returns an integer, which is the actual index of the location of the chunk in that array. You pass in the chunk list, and then you also pass in the pointer. So it'll check for the pointer. If it finds it, then it returns the index location of that, or index location of that chunk with that pointer. Then we have remove. So this removes a chunk from a chunk list, and essentially it just takes in the index as an argument and removes the chunk at that index. Then we have insert. So that does exactly how it says. You basically pass in a chunk list, and then you pass in the information that's part of a chunk, so the starting location or the start pointer and the size of it, and it makes a chunk and then passes or puts it in at a index location. Then we have a merge chunks, which is mostly dealing with the fragmentation, which essentially uses a source chunk list. It takes all the fragments, combines them together, puts them into another chunk list, and then it basically just combines all the fragmented sections into one, and then puts it into the destination chunk list. So moving on to the malloc. So for our malloc here, we're going to be putting in, or it's going to take in an argument of bytes. And using that argument of bytes, we're going to find the size in words. So this refers back to when I was using the pointer-sized elements inside of the heap. So we're never going to, I know the actual malloc representation either returns a unique pointer or it returns null on an attempted zero-sized malloc. In our case, we're just going to return a null. There's not going to be, you're not going to be able to allocate 0 bytes or a zero-sized memory essentially. And then essentially what it does is it just goes through the free chunks. It finds a free chunk that has enough or a large enough size to fit the size that we're looking for. It removes that chunk and then it inserts it into the used chunk. So now that free chunk that was previously in the free chunks array is now going to be into the used chunks array. And we're going to subtract the size from the original chunk that we took it from and add that one back into the free chunks. And then also return the pointer to that chunk that we took out of the free. Going into free, the myFree implementation. So it's going to take it into pointer because you want to, of course, free the memory at that pointer. You're going to get an index. You're going to get the index from find. So you're going to find a chunk in the chunk list. Specifically use chunks because you're not going to search free chunks to or deallocate a free chunk already. So you're searching through these used chunks with a pointer, and you're going to find that. And since find returns an index, you're going to get that index back. Here's just some sanity checks. Index is greater than or equal to 0 because you shouldn't have anything lower than 0, of course. And then you're making sure that the used chunk start is actually that start at that index. And essentially, you're going to insert that chunk into, or the current chunk that you have into the free chunks, and then remove it from the used chunks. So it's almost self-explanatory. You just take that chunk that was allocated and you put it back into a free chunk list, at least. And then you would merge the fragmentations. So in the video that the guy was explaining, he mostly went and did these merges down here that I highlighted. He would do them up here in the malloc. So essentially, when you're allocating size or allocating a specific chunk to the used chunks, he would merge the fragmentations together just in case to make sure there is a large enough section or large enough chunk so you can fit your malloc in, or so you can actually allocate space in. Whereas I just put it into free, so then there's always just one chunk essentially in the free, which should be, I mean, it'll be slower because you're going to be merging a chunk every single time you free, but you'll have one chunk every single time. So I'm not going for the most efficient malloc and free, but it works. It makes it so there's no fragmentation. And yeah. Now moving on into the actual garbage collection. So essentially, what the garbage collection does is it makes a pointer to the current stack location where this is made, this method is made, and it also uses this pointer, which points to the base of the stack for the whole program, because main's going to run first, so you're going to get this stack right here. You're going to get the base address for the stack, and that's used so you can find the different pointers within that stack range. And then it essentially goes into mark region. Mark region is a recursive method that finds the chunks with it, or finds the pointer within that range that I was talking about. So it's going to be between stack start, which I have here, which is our start value in the mark region, and then it's going to go to stack base plus 1, because you never actually want to reach stack base. And it will recursively call through there, through different chunks, looking for if any pointers match. And it's incrementing by chunks. So using this uint pointer, you're always going to be on a chunk or on a location that is the size of a pointer. So if you don't have to do any like conversions, since the memory alignment in C works pretty well with this, so you don't have to do any conversions for anything. And every spot should, if there is a pointer there, it will be identifiable. Like there won't be a pointer in between two bytes. At least there will be a pointer in a certain chunk of bytes. It won't be in between bytes, so you won't have to do. Yeah, essentially, it just creates memory alignment, essentially. And then once it finds those reachable chunks, it adds them to a freed list, a to be freed list. So we have a free count here. It goes through the used chunks, finds if they're reachable, and adds them to this to be freed chunk list, which are, I think it just adds the pointers in. No, so it just adds the pointers in to this, and then you go through after that, and you go through to the size of the count, which we increment in here for every single pointer that we add in there. You just increment through this for loop for all that, and then for every single pointer in there, you just call a free to free all the memory that's in between there. So essentially, it's just calling a method to do the garbage collection, to go through the pointer or go through the stack, find anything that's pointed to the heap. If you find one, add it to a local array, or add the pointer to the local array, and then go through and deallocate all of those pointers with the myFree. So if we take a look over here at main, there's that stack base that you're again used in the other thing. What we're going to do first is we're going to malloc off a large amount of space 5 times here. So you're mallocing space. And then the chunk list dump just dumps the chunks out in a nice orderly fashion so you can see where everything is, how everything's working. And then you just pass in what kind of chunk list it is. So this is like the allocated chunks, the free list, or the free chunks. Then we're going to collect garbage. So it should show in here the malloc space. So it should show maybe 5 chunks that are allocated when we dump this used chunks. And then it should show one big chunk right here of the free space. And then we're going to collect the garbage. So it's going to go through the stack and find any of the pointers that are on there and take them out, or deallocate them, I guess, if we're using correct terminology, which will essentially just take all of the used chunks or used pointers and free them, and it'll put them back into free chunks. So what we should see in this section right here is just 0 allocated chunks and 1 large free chunk. Basically, that's the size of our original heap, because the free chunk will point at the original or the start of that heap. Then we're going to malloc space again. We're essentially just going to do the same thing again, just with larger arrays or a larger amount of bytes. So we're going to do 100 and then just malloc a ton of space off, and then show that space that's malloced off or allocated off. Collect the garbage again and show that it was collected. So if we move over into our terminal here, like I was saying, we are going to allocate space for the 5 arrays or the 5 chunks, which it does so here. It allocates off 5 chunks, each with different size, because we are doing the I times size, or I times a certain value. And then it decrements the size here. So we have one big free chunk, which is this size. And then we have all of our allocated chunks, the 5 allocated chunks that we allocated in that for loop. Then we're going to collect the garbage, and here's our dump, or our chunk list dumps now. So allocated chunks is 0. So we have 0 chunks that were allocated. And then since all of them were freed, it's going to add it back into the size. It's going to be 1 large free chunk, and the size is the original size that we started with. Then we do that again with just larger chunks. So we get down to 20K for the bytes, I believe that is, or the words. That might be 20K words. So it's going to allocate 31 chunks. It's going to, basically just put them all into the allocated chunks array. And then we are going to have just the 1 free chunk left in here, the remaining size that's in the free chunks. And then we're going to collect garbage. So go back through the stack, find everything, find all the pointers, and free them.